Okay, so we're now going to do the ball kicked above the ground. Speed is 7 meters per second. So the first thing is that we need to draw a diagram. So we have got a ball being kicked, 7 meters per second. So we've got it initially going off at 7 and it creates a 60-degree to the horizontal. What is the height p above the ground if it's caught 1 second after it's thrown? So we're going to say that that is equal to 1 second and it's caught, and we're trying to work out the height y. So first thing is we need to work out the vertical and horizontal component, although actually because we're only dealing with the verticals, this is giving you an example of why using column vectors would kind of give you extra work that you probably don't need to do. So although I did say that I could do it in column vectors, in this case I'm going to choose not to do it. So we've got our y that we need to work out our initial speed in the y direction. What we have got, if I just draw a diagram, just to separate that out, we've got 7 as the hypotenuse, we've got a 60 degrees in there, and we've got the height, which is going to be u, y. Now obviously there's an x component to that, but we don't need to worry about that. So when we're looking at the vertical, it's v sine, so we end up going 7 sine 60 to get us an answer of 6.06 to 2 decimal places. So 6.06 meters per second is the initial speed. So we're now looking at the equation s equals ut plus half at squared is the Suvat equation that we're going to use, where s we're going to class as y because we're only interested in the vertical component. So you might want to make it clear that you're just working in the vertical. So y is equal to u, 6.06, times by 1, because it's after 1 second, minus g times 1 squared. So we end up getting that y is equal to 6.06 minus 9.8. Oh, I forgot to half it. So 6.06 minus 4.9, which gives us 1.16. 1.16 meters is where it is caught. If instead the ball is not caught, find the time taken to reach the ground. So we're now trying to work out time to reach the ground. Now, when it to reach the ground, if it starts here at 0, we're basically looking for s to equal to 0. So we can take the same equation, but this time we're going to say that our displacement is 0. So 0 equals 6.06 t minus half gt squared. So we've now got an equation that we can solve this. Remember, take out common factor. Remember, g is that ends up being 4.9. So we can factorize it by taking out the common t, which means it's 6.06 minus 4.9 t, which means that either t equals 0, which should make sense because it's at the start, it was there, or we can solve this, so we end up getting 6.06 divided by 4.9, which gives us an answer of t is equal to 1.24 seconds. So 1.24 seconds is the answer for the last bit.